Hello, everyone, and welcome to today's webinar, FSA-AIA Course Preview, brought to you by the Fabric Structures Association. This webinar is presented by Mar Ricketts, FSA board member and principal and founder to GuildWorks, and David Bowick, past FSA board member and principal at Blackwell Engineers. My name is Megan Furl, Education Events Coordinator here at IFAI, and I'll be helping to moderate today's session. Today's session, you'll have the opportunity to submit questions or comments to Mar and David by typing them into the questions box of your control panel. You can send in your questions at any point during today's webinar and we will address them. Today's webinar is also recorded and you're going to receive an email tomorrow coming from GoToWebinar with that link to watch the recording. With this, I would now like to pass things off to today's speakers, Mar and David, to get started.
Hello, everyone. Thanks for joining. And I hope you're all excited to see the course that's come together for you all. This is actually the first one in two courses that the FSA is putting out to members. This is the Introduction to Fabric Structures. It is registered with the AIA for CES, and we will also be registering with PLSA Landscape Architects come the beginning of the year, so you can give continuing education credits for both AIA and landscape, because we think both have good potential for bringing work into our association and industry. How we're going to do today is we're not going to actually run the course as if we were presenting to an architect. We're going to talk a little bit about that, but we're also going to talk about what it is to be a member of the Fabric Structures Association, what it is to give this course representing the whole of the Fabric Structures Association, as well as representing your expertise. We want you to remember, yes, if you're going and giving this presentation to architects, you're the expert in the room. Remember that. Don't count exclusively on the material here. Show your expertise, and but also cover the broad range of the material shown in this slide, because we really want to give an overview what is possible out there, and know that here's the description, but know that if it's not what you do, there's someone else in your industry, in your association, who does this, and you can still be the expert passing off a job and securing another job for your company. So the goal of this course is to give an overview. It's really pretty basic, and I think the idea is to give material that none of you feel concerned about giving. It has a lot of imagery in this course. So what are fabric structures? What are the building materials? What are the types? How can we classify them and know a little bit structurally about them? What are advantages of material choices? What are options? And kind of where will we find these things? So you'll see, kind of go through this in a variety of ways here. And again, we're trying to set this up for you to be successful in giving this course. I also want to mention I'll be doing a lot of the presentation today, and Dave is going to be looking to your questions, adding in more details in each slide. So I'll kind of kick off most of the slides, and Dave's going to follow up, and he's going to be looking for your questions. As we said, feel free, especially if it's in relationship to a particular slide, feel free to put the question right up there, and maybe we can handle it right then instead of trying to go back. It'll be good to talk about in that course.
I'm the official peanut gallery, right, Mar?
That's right, your official peanut gallery. So there's always learning objectives. What do we really want them to come away with? And to come away with learning, you've got to go through it sometimes a couple of times. So defining what are architectural fabric membranes, and I want to stop right here. There's two words, and we talk about the Industrial Fabric Association and the Fabric Structures Association. Well, we want it to really be insert this word membrane next to fabric, because the way IFAI looks at fabric is much broader than what is merely woven or knitted. So it includes these membranes that, like ETFE, that are starting to lead in the marketplace of big expanse of what's possible and what's out there. So you know, that's why it says learn basic fabric foil. Again, this is fabric membrane, fabric foil types. So we want to be clear about, we're starting to include that word more when talking about our industry. Basic divisions, these are types of fabric membrane structures. How do we classify things? And sometimes it's hard because they're hybrids, and we'll see that. We're always talking about advantages and considerations, and I think all of you as representatives and owners of companies out there are always thinking about this. What are those advantages? That's how you sell something. We are generally, besides being, you know, beautiful, interesting, we're also trying to serve an architectural function in what we do. And applications, again, you'll see some of these things circle around, so that I'm hopefully through the course of this presentation touching on them a couple of times. So the first one, we're going to talk about what is an architectural fabric membrane structure. This is broad, and I want to start with a broad slide, kind of a diverse, and I'm not even showing the full diversity here. Architectural membranes help reshape the way we imagine architecture. That was, you know, put in there just like it's an original and unique building material. How can we rethink about everything we do? And one of the things we know as the board of the FSA, and has talked about a lot, is how architects tend to think of their standard materials. We have concrete, we have bricks, we have glass. Membrane is an original material, and we want to make sure that's in their mind as a way they can build. What's innovative about using fabric structures? How can tension element, you know, it brings an innovation that has many benefits, and we'll talk about the benefits more. I'm going to go through some of these quick. But, you know, lightweight, minimal material, something, again, I think you all know, but we really want to point that out to the architects, is the, you know, less weight characteristic of less steel, less materials in the project than a comparative other way of building. It's weather protected.
This would be physical lightness as well as visual lightness, right, Mar? I mean,
that's right. Yeah.
Visual lightness.
Yeah, that makes a lot of the beauty, the visual lightness, the light quality coming through it. All of this, absolutely correct. Weather protective, you know, what are we trying to do with the fabric and the abilities to handle that, work with that in this kind of lightness way, minimum materials. And to jump to this one, sustainability by design. Now, sustainability is a big buzzword out there, and you know, you have to be, we're working on that a lot as a company, but it takes a lot of groundwork to really say in a classic certified way you're sustainable. But there is something inherent in the design of fabric architecture and the minimal materials that by nature is sustainable. And this is what we want to put out there, that, you know, look at this, any of these structures, especially where we're under them on the upper right, lower left, there's very little materials compared to the span. The shade structure is super minimal to put up. And even this large rain canopy on the lower left, look how light all of this support structure is. You're just not going to get this level of material minimalization in any sort of other structure. And I think that points to the sustainability, because we're pulling out less of the earth, we're transporting less, our installs are efficient. Again, we're going to touch upon these points all along, but it's something that I think each of you and all of us as an association can really pitch, is that the design, the basis of design is sustainable. And then we get into cost effective. Architecture costs a lot to build, and fabric structures can can be expensive too, especially when there's a lot of details, but they can also be pretty much the most affordable way we can build. And this is always a tricky point, and always in my experience of giving this presentation becomes a question. The architects want to know, well, what does it cost? What does it cost? And you're not seeing it now, but on the note side, we're giving you a couple of notes about, price ranges. Like, yes, there can be simple air structures that, might cost teens, 20s, dollars a square foot, but, very expensive, very elaborate fabric structures, PTFE, lots of details, could be a couple hundred. It also depends how much square footage. So it's more about, I think, in talking to the architects, it's really about the items that influence the cost, and reviewing these, talking it through, developing that process. But you've got to give them kind of some background so that they get a sense that also they have to head to experts to figure this out. I don't know what you would say to that, Dave. I'm curious about, you're talking to architects in price point. What would you say?
Yeah, well, we typically say start with 150 a square foot, but you might be north or south of there, depending on the complexity. And then we also point out that cost is so much a function. We want a rule of thumb that's about surface area and covered area, but in fact, cost is much more about the amount of boundary. In fact, it might have come from your office, Mar, where the surface area wasn't even calculated the length of the boundaries and the number of details, and that's how things were costed.
Yes. That's right. I find that much more important in my calculations than the square footage. Yeah. Thanks, Dave. So what are some applications to fabric membrane structures? We've inserted these slides of questions, both to stop the visual onslaught of all of the photos and just to give a reset into thinking about, you want the architects to think about the applications. You want them to think about the advantages when we get there. So it's kind of giving a breath. And then we can go on, whereas these other slides, once we're in it, are meant to go kind of fast, unless you really feel like if there's something here that you're an expert in, by all means, use that area to expand it a little bit, show your expertise, and then show the broad range of the solutions available. And by no means does this presentation cover the broad variety of fabric structures we're trying, but there's a lot out there. So roofs, I mean, it's a simple way. I'm pretty large scale here. Roofs are also small scale, and you'll probably see, just to talk about timeline, when we republish this presentation, actually send you the PDF so you can go out and start to give it, allow you to schedule come the beginning of the year. There'll be some extra inserted slides, more diversity, things like that that's getting worked on by the board now. So roofs are a key way. Facades, this is a up and coming use that's been around a while, but it's rapidly changing in our marketplace from small scale to large scale. And we could, you can go into talking about the advantages of facades, to go to a membrane facade, to be able to print it, or to cut down the cost while having some of the basic support structure be less expensive than they would want to detail it otherwise. The light quality in facade, in all fabric structures, skylights, atrium structures, it's again another application of roof, but a little more specific of an application. Large span, this is one that, fabric structures are really the only possibility when we come to really large spans, that otherwise you're just too much weight in other materials to do. And so this is why stadiums are built to fabric structures so often. Full building enclosures, this is one where the architects, how do the architects think about the membrane structure, and often they're putting in a bubble like, oh, it might be an awning, it might be a shade structure. Do they think of it more inclusively? Like basically this can be almost all of your building. It depends on the application. Everything is based on application, of course, but shade structures, I hope a variety of you are in the shade structure growing industry, and they can be very heavyweight or very lightweight, but the great thing about shade structures is they can be so lightweight, so minimal, but yet provide so much protection that's needed in this time, especially that the world is in. So we want to really focus there as well. And I don't want to forget all the interior work, all the art, the environment, the things that you wouldn't typically classify as, oh, a roof or an atrium or these kind of big architectural features, but they're very important to some of your business models, but also to, you know, how a place feels and how it comes alive. Okay, so materials, architects always want to know about materials. And one thing I've said, you know, if you're in person, when I've done this course in person, it's great to take along a sample of materials. You might not have everything. You can call the manufacturers of the materials and get samples. They'll happily send them to you, even if they're not ones you typically work with. And then you kind of show differences, because again, we're trying to get this broad sense of what is out there. And we want to expand fabrics and say fabrics and foils again. So the fabric is weaving or knitting, whereas the foil is an extrusion process. So, and this is one that I'm asked, you know, can natural fibers work? I'm sure you've all heard this, architects wanting natural or owners wanting natural. Well, we're meeting a lot of standards and a lot of specifics, fire code, other performance needs, and the synthetics are capturing that. There might be some naturals that can capture some of that, but in a large part, as we all know from this industry, we're using synthetic fibers that hold up and are better solutions than natural fibers due to their longevity, due to their meeting codes, and that everything that we're going to present in here can meet the code requirements. And different code requirements and different function requirements are going to require different materials. So what materials selected? Well, that you have to look at what's the performance criteria for the project and what's really needed. And that's the job of the fabricator, the designer, to work with their client and give them the expertise. And this is, again, what you're giving this presentation to give a broad sense to the architects, the landscape architects, but also to paint that you're the expert in the field and the members of FSA are experts, and no matter what it is, we can find the right expert to help them do their job and to figure out which material, what sort of structure is really best for their needs. And this list of different fabrics isn't at all complete. It's kind of a quick overview. There's new formulations, new coatings, all of that out there, but we're just going through a little of it. I think a lot of this is what you do going to the trade show and being aware. So unless there's specific questions, you know, this isn't one I'm going to spend a lot of time with, but we're trying to give the architects a feeling of it. And in an architectural presentation, you might spend longer here or on some of them because the interest, they have a, you know, something that links to it. Hopefully you keep a project specific question towards the end. If they're asking you like, oh yeah, I have this project, say that's great, can we stay after the presentation and we'll dive into your project a little bit, because you want to make it through the whole presentation. We're going really fast here because I'm guessing that a lot of you know the basics of this, and if you don't know the basics, we'll be sending it to you so that you can review it, you can ask back questions before going to present it.
One thing I try to do, Mars, is when I'm talking about a material, try and make a reference to a material that an architect would have had experience with. So like a tactile experience with. So with acrylic, for example, that's like boat cloth material, right? Everybody's been on a boat, or awning material
right.
that you would experience. So this is not tensile structure material, but now they kind of know how it feels, and they know what we're talking about. It's no longer a word then, it's actually a physical substance.
I think that's very important, you know, and just like the shade cloth, a lot of them have seen shade structures. Maybe they've only seen it at, you know, less expensive playgrounds, you know, kind of minimal uses, and you're, you know, projecting something much more elaborate like the picture, but it can still use the same material for affordability, because this is an advantage, you know, in this material while having great UV protection, great solar protection, etc.
I know we're not giving the presentation now. This is the how to give the presentation, not the actual presentation. But I want to ask you this: on the shade cloth, because it's knit, it's actually quite a bit more flexible than the woven fabrics, isn't it?
That's right.
Because it's more flexible, it's easier to pull it out taut without wrinkles. It's like if you want your pants to fit without wrinkles, then you buy spandex pants. You don't use your canvas fire hose pants if you want them wrinkle free.
That, I mean, that's super true, and it's a cost advantage, not just the cost of the material. If we talk about the affordability of shade cloth, because here we're in materials, but there's a cost ratio factor, and that cost ratio is in the actual material cost, but it's also in the details. Like if we're putting up the opposite end of the spectrum, we go to a PTFE structure that has to be so precise and so many details to put it up, that every single one of those details and precision and the care and handling, we can't just fold it up. We got to be careful we don't break the fibers. That is all adding cost. Where here, like this can be folded, packed, you know, however, and there's a lot of flexibility in, oh, the post didn't get set quite right. Well, there's a lot of range. The turnbuckle can take it up. The fabric structure can stretch a little bit. It's going to work out and look nice. And this is an advantage to architects. I think, you know, shade structures, all of the fabric structures, all of the FSA has just, I feel, and I think the whole board feels, everybody I know in the industry feels that there's just such a growth potential. It's really needed. And if architects understood how to make, you know, shade structures look nicer, look more integrated with their architecture than just plopped on after the fact or a playground, not that those aren't great things, but we would see more of them. So there's advantages to point out. Polyester, there's other fibers used in interior projects too. As I said, this isn't complete, but interiors, what's done for the display space or even divided space. I mean, this is this lower example I really love, because it's not even hooked into the architecture, but if you look at its function, these screens are an architectural function. They are dividing space into kind of a larger space, into rooms, into hallways. This is an important aspect of what can be done with fabric compared to, oh, imagine if they had to build a framed wall to do that. What was their expense, the demolition when they want to change the museum show, etc.
Another advantage to the polyester, an open, uncoated weave is acoustically, if not invisible, it's not highly acoustically reflective. And so these can be incorporated into acoustic absorptive panels and things in a really wonderful way.
That's right. Very true. And we could add that to the slide. And as you'll see when we republish this, we're going to keep working on it. You know, it's to kind of make it represent, we want it to represent everyone's work. So in the industry. Coated polyester. This is one of the mainstays of, you know, a large part of the Fabric Structure Association. for its rain protection, you know, being able to hold up to all sorts of weather-related loading and extreme factors, while having an affordability, a flexibility. You know, this is not nearly the affordability of a shade structure using HDPE, but it's not what a PTFE fiberglass structure is. So, and there's the coatings, and there's a lot of talk about coatings, and coatings are very detail oriented. And we want to talk about them a little bit, especially these top finish coatings. But don't expect, unless this is your area of expertise, to be the expert. And we're trying to give a broad sense of the presentation. The other thing I find is that, you know, PVC always, and I think a number of you find this, and Dave, feel free to comment more on this, it gets a kind of a pullback from almost everybody. But with the top finishes, those are protecting the PVC from full off-gassing. They're protecting it from breakdown. There is more recycling coming up online. It's not here yet, but it's coming. This is, and if we compare it back to, remember, we're talking about design principle, the minimal material, that's the sustainability factor. So using the little bit of PVC we're using in our top finishes might have no sustainability, or really, like, it's almost invisible compared to some standard building materials that people might not think of. It's just because we label that PVC up front. So we're using some of these advantages, you know, both in the design sense and in this material sense, to kind of give, you know, substance to why you might use it. And say, you have something, Dave, to add to that?
Envelope too, right, Mar? It's PVC and PTFE, the coated fabrics, because I mean, any architect listening will know that the one thing you can be certain about is envelopes leak. I mean, that's why we have rain screen walls, because we know that they leak. But in fact, you've almost got perfect integrity with these coated fabrics in terms of leakage. And then the architect is going to say, no, I did a PVC roof on a house and it leaks like crazy. But it doesn't leak in the field. It only leaks in the field transitions, you know, where you've got a field joint where a parapet meets the roof membrane or something. But otherwise, the integrity is nearly perfect. And so you see these facades, one giant piece of fabric on a facade with very, very minimal boundary, and you've got a much better envelope than just about anything else.
That's right. And so the material is perfect in that way. The standards of making all of these materials, our whole industry, the standards of the materials as they come, being a fabricator, I know that they're amazing. I mean, if we compare them to 15 or 20 years ago, the whole industry, the detail, the finishes, everything has gone up. And it's just that is not going away. That's just increasing as technology becomes available. So it's really then about the details that the design and the fabricator put into place that control how this thing doesn't leak. And like you say, some of those meeting of PVC to, you know, in traditional ways on flat roofs, et cetera, you know, those aren't done in the same technologies that we often use in our industry that, you know, are much better at keeping leaks away. So this is to bring into the architects. And there's PVC, the color advantages. There's all sorts of the flexibility, the ease of fabrication. So all of those make an economic advantage.
Now PVCs, even though they can control flame spread, the PVCs are combustible, so that is a disadvantage of a PVC. And it is acoustically reflective. You know, fabrics, they have a benefit of a psychoacoustic perception, that because they're soft, people assume that you're in an acoustically absorptive environment, but they're actually, tension structures are highly reflective and acoustics have to be mitigated.
That's right. Yeah, they have to be really looked at, especially where it matters. And fiberglass, now here's a case where the base material, the fiberglass, of course, is non-combustible, but the coatings, don't necessarily meet that. So we're always in a little bit of strange zones, and fire codes are something that have to be looked at carefully when building fabric structures. This is why FSA pays a code consultant to always be kind of helping us stay in tune with the codes. So a lot of large scale fabric structures use PTFE coated fiberglass. The strength, the durability, and the lasting capability of PTFE, it's said 30 years plus. We really don't know. I mean, the earliest PTFEs are now over this lifespan, and some of them are starting to be replaced, but not all of them. So it's really a long lifespan with PTFE. There's also some interesting, you can always throw in a little side note. It's the only material substance that a gecko cannot stick to. So the self-cleaning word is thrown out a lot with PTFE, and while that is true, the rain can rinse it off. It's careful because it's not like it actually goes out there and scrubs away. But if exposed to enough elements of water run or some light cleaning, say if it's inside air and it's just the molecules are sticking there, a really light rinsing of that surface could bring it into clean. So it's a non-stick property, and that's why PTFE also is best known as Teflon. We're not putting that word on this slide because it is a trademark, and it's not all PTFE is Teflon. So, but feel free, you can mention that, because then the architects might be able to connect to it. We just don't want to put it front and center because it's actually broader than that brand name.
It's tremendous to know that if you have a gecko infestation, that a PTFE roof will help. I want to say with PTFE is the one, I think the only fabric that is non-combustible, which of course tremendously expands the range of possible uses in buildings, which is why you see it over, if you've got shopping mall or an airport or major public buildings that are required to be non-combustible. Can use PTFE.
That's right. Yeah, if it's pure PTFE fiberglass, you've got it handled then. The flexibility when you get rid of the fiberglass and you just work with a pure expanded PTFE, as you know, in a lot of these kinetic structures, of course, you can do kinetic structures out of acrylics if they're simple Roman shades or something, and those are beautiful and functional too at a small scale. But a large scale structure, this is really, that is collapsing. It's really the material of choice. It's not, the disadvantage here, I put budget, because it really is both fiberglass PTFE and pure PTFE. The fabrication is really tricky. Even the site welding is really tricky and time consuming. There aren't that many fabricators with the material. So all of that falls in the disadvantage range for how to get it out there more at the current moment. This will all expand in time, but it's just understanding those limitations that might have an architect or a landscape architect look more at a PVC or a simple shade structure than saying, oh, it's got to be PTFE because we want that huge long life. Well, is it worth it to pay for the long life, or is it maybe going to be easier to plan on replacing the fabric? So again, it's probably more about that consideration. Does it have to be non-combustible, or does it have to be 100% waterproof? I just heard one the other day where they were planning a PTFE structure in the middle of a campus from one of our board members. And he said, wait, you're talking about this as a shade structure, but you're building a PTFE structure in the middle of the campus. What, is everybody going to run to that structure for solar protection? And are you planning it for a storm? Maybe using that budget and expanding it more as a shade structure makes sense. So all of these things, there might be a material they really lean to, but what is the application? And
ePTFE is the availability right now is questionable too, isn't it? We've been discouraging people from looking at it because we don't think that they can actually get it right now. We understand that somebody is going to bring it back in, but another advantage to ePTFE, because it's all one material, it makes it much more recyclable. Is that not the case?
It is definitely the case. It's so much easier to recycle this product, PTFE and ETFE, which we'll get to along with HDPE. These are kind of, these pure products are really where our recycling advantage is. HDPE, LDPE, polyethylene in both high density and low density. It's, seen more and it in kind of industrial applications as we focused here, because the actual close-in feel, the look, some other features about it maybe isn't what is wanted for the architectural, but on an industrial level, it is an amazing solution that is really cost effective and also very recyclable. And the ETFE, which is a very PTFE, ETFE, these are in the same chain of hydrocarbons that are making these just some differences in it. So we're getting a lot of the same UV stabilization, the long life. Just ETFE as a foil has this ability, it really stretches a lot. So the characteristic use has to be designed into the fabric really carefully. How do you deal with that stretch? How do you put that pre-stretch into place? In the pillow situation, it's often the pillows that are designed to keep it tight over time. There's single layer and there's pillows, understand both, but the stretch is a factor in the design.
Short spans and large curve or large curvature, right? In order
That's
to
right. A combo, yeah, have to be used in this material. So really a lot of design, a lot of fabrication sense, but I think this is one area we're going to keep seeing it expanding. And I'm imagining that it's not just the specialty large manufacturers that deal with large scale architectural items. That's who's currently doing the ETFE, but I really think, and the slide in the upper right is larger scale, but imagine that shrunk down. I mean, small ETFE canopies for being under is a totally feasible thing as a lot more FSA fabricators get into, oh, what does it mean to build with ETFE, and kind of let it percolate through the architectural world more.
The fire performance of ETFE is fascinating because it's a combustible material, but it in the presence of fire, it doesn't drop globs of molten plastic. In fact, it burns and then voids the opening, like it sort of burns to the boundaries and then stops. And it won't sustain combustion. So if you hold a lighter to ETFE and then you pull the lighter away, the flame goes out. So it can be demonstrated to be fire safe even though it doesn't pass the non-combustibility tests. So we're using ETFE on very large public projects that are required to be non-combustible. We can demonstrate acceptable fire safety.
That's right. It's essentially the IFR, and it has the same features that a polyester used inside does, because it's the same exact thing as a polyester that's used inside. It's like it's just going to disappear in vapor, but the good polyesters are not dropping any globules, so therefore they meet the fire regulations needed. So it's the exact same principle at hand. So, and in an ETFE where you're doing a roof, the fire marshal can even tend to like that, saying, I've experienced some where it's like, okay, that makes sense. It's actually going to open up a smoke release,
Yeah.
So. Okay, so we want to classify divisions of fabric structures, give the architect some framework to say, what is the structure design like? What is the framework? What is the system used here? So tension fabric structures, variety of scales from the lower left, one of the most known about in our country, the Denver airport. huge scale of project, gigantic. But tension fabric structure is in most, shade structures that are just pulled. So it's using the efficiency of the tension material. There's essentially, you don't see much in the way of horizontal compression members, horizontal steel members. The tension structure is lighter overhead, often uses cable technology tied to it, but doesn't have to. But because it's the fabric in tension through a large span. And here, curvature, the design, the curvature is a really important stabilizing feature. And you notice it in Denver Airport, where we have a high snow load, a high degree of curvature in the design of this structure. Frames support it. Again, they could be very simple frames. There's a lot of work done with simple frames. These are some rather ornate frames showing diversity of frames, but the frame system is very easy. And then using the fabric as a membrane over that, it's still a lighter cladding. And this is still, even though we might say, oh, this has a lot more framing than a tension structure, this is still a lightweight structure. And we want to really bring notice to that. Any other cladding, or especially a rain protective material, is going to add a lot more weight, or shade protective, so to the structuring, even though you might use the same structure system for a different material. Grid shells, another lightweight technology where essentially instead of large members, we've evenly distributed the smaller members to hold big shape and forms, and has a lot of double curvature in most grid shells. Is really kind of artistic, but it is kind of its own standalone type of structure. So we want to note that, and frame support it.
It really integrates well with fabric, right? Because the grid shell is a form active structure that depends on that double curvature for its structural integrity. And the fabrics are membranes that can accommodate the double curvature and complex geometries in a really, really well. So we're seeing, that wood grid shell that you showed, I'm pretty sure is a single layer ETFE roof on that one.
That's right. That's right. So, geodesic dome, again, it's a great material, and there's a lot of relation between grid shell and dome. A dome is just, kind of has that simpler shape to it that's going on here. And but again, combined with a fabric material, it's really a perfect example. And we have examples of multiple different thicknesses of fabric here, and also ETFE cushions being used on dome structures. And the other is that the fabric, both in a grid shell and in a dome, depending on how the fabric's attached, the fabric can help stabilize the whole structure. It does in Eden project and on the lower side of this, and it does essentially for a lot of grid shell structures. So the tension in the fabric can be advantageous to the structural system. We see arches used a lot, so we're separating that in frame supported just because there's an structural efficiency in an arch. Traditional bridges, you've seen arches a lot versus straight members. There's just a structural efficiency to the arch. It also creates a feature, so fabric's able to work with that feature to find that feature. So there's many sorts of arch structures and arches put into structures, many different ways and detail levels to do that. But to kind of notice that the arch is an important structural element and frame supported that separates the type of the structure. And then we get into panels when we get into paneled structures, paneled divisions that make things kind of systematic to build and install. These panels are used a lot in facade projects. And we can also think of panels as cells if they really become three-dimensional. So there's a lot of variety in frame supported, and I don't think this is representing the full variety here, but you can kind of see we're showing a lot of options. We're not showing them all, but we're trying to diversify that architect's view of what's possible. And who knows what they'll grab from here and link it into something else, another application that gives an opening for a project that never has existed before. Cable nets. Now, there's a lot of different cable nets, but cable nets are great for long span. They're great for high loading support. There's a lot of diversity, and in the upper left, Fry Auto, this is where the modern industry started. And cable net before the fabric materials were around that allow us to do what we're doing today. So we've got to give a nod to that important milestone and note that, you know, this isn't really, though fabric is our oldest material that made architecture on the planet, the original material, like that FSA quote, but it's also, we're in a really modern industry. Don't forget that each one of you are in a modern industry that hasn't existed even for 100 years, and we're going up against balloon framing and concrete blocks and bricks. There's a lot of education that we need to do. So we're still in the early days.
I think of this like grid shells that cable nets rely on that anti-clastic compound curvature for their integrity, which just makes them so so symbiotic with fabric structures.
That's right. Yeah, I mean, it's basically taking that form and turning it into a line. And as we know in the analysis side, this is kind of the early ways these structures started to be analyzed, because it was too hard to analyze the whole membrane. So you thought of the membrane as a whole series of light cables. So it was one of the early ways it was looked at. And to expand the cable even more, the kind of tensegrity feature, now there's what is actual tensegrity? If we look at true definition, it's these floating struts, but we might say, well, the upper right has these continuous members that aren't part of that design. That might be true for the true technical, but we are using a tensegrity feature in a lot of fabric structures, especially long span, large loading fabric structures, to improve the stability, because it's a very easy stiffness that those vertical members are adding a great stiffness to this otherwise very thin shell.
As soon as you've got a compression element that's held in place only by tensile elements, not connected to any other compression element, then I think you've really satisfied the definition of tensegrity, haven't you?
Yeah, you've satisfied it on one for that micro element, but the whole structure might still not be, you know, in a maximum form, is it a tensegrity structure? But we're using tensegrity principles, and people notice that it becomes an architectural feature. It's a defining feature. So I think air supported. Air supported is used a lot in industry, and because of affordability. I mean, these are for a full building enclosure. Talk about affordability. This is the cheapest way to go. It's also able to go out to a field, make a building for a period of time, and then take the building away. It's just fabric and the air handling system. So there's an incredible advantage to it as far as materialization, and we don't want to forget that advantage when looking at the design. Again, it's what is the need? What is the actual program for the space? And then there's air inflated, which has a very similar ease without much structure, but often has a lot more fabrication time built into the skin of it, holding the shape, but could be much more architectural, really handles some amazing features or amazing functions. So on the left, we've got features. On the right, a little more, we have function. So kind of what is that defining factor, you know? So there's air supported, there's air inflated, so that we're actually making a rigid wall in the air inflated of these tubes.
As soon as you're pneumatic, everything wants to be a sphere or a cylinder, right? And that limits you in form. But the air inflated elements are just made up out of cylinders, but gives you an awful lot of flexibility.
That's right. There's a lot of on design of all of these structures and patterning. It's I'd say a lot of detail work to understand the final form compared to the predicted form and where the materialization affects it. So air inflated and really air supported are both very specific fields in fabric structures.
Now, a major distinction is that in an air supported structure, you are occupying the pressurized environment. So you need to walk through an airlock to enter an air supported structure. Whereas air inflated, the pressurized environment is within the pillows, and so they're kind of a more user-friendly building in that sense, that they're easier to inhabit. You can have open doors, you can have big open walls like this hangar structure with air inflated as opposed to air supported. There's a reliability issue though, isn't there, Mar? A little bit of you know, you can only
in both of those, there's always a reliability, and there needs to be backup air systems. So you know, everything in fabric structures, there's no one correct answer or one way to go. You have to check what you're trying to build, what you're trying to achieve. This is where you're the expert, and you can really tell that story to them as they're asking about it. And you know, even if you're not the expert in this, someone in the industry is, and it's all a matter of, yeah, what systems, what are you trying to achieve, and what do you need to put in place? You know, air structures, you have multiple backups, you have, you know, backup power, backup blowers, etc.
And manual intervention in big snow events, right? Because
yeah,
you can't inflate, the inflation pressure can't be as high as the snow load generally, which means there's interventions required potentially. So it's just, that's obviously just a thing you manage. You have to plan for it and allow for that.
And the same holds true here in retractables. Retractables are one of the new things that are really more and more online, but there's, you know, traditional retractables in Roman shades and such like that that have been around. But retractables need that backup power. They need to know if they can't handle the full loading, how do you make sure that they're ready to fold up? This is part of that detail, code compliance, other step of it. So, but really a lot of diversity, and a lot of people really want this, developers. And hybrids, we won't talk long, but there's, you know, what are mixing technologies? I think there's always new fields where from new forms created from taking something from one, combining it with something from another. And sometimes you might find that by introducing all this material to architects, even though you might not be a fabricator who traditionally does this type, they see a road to combine what you traditionally do with something they see in here, and might open up some sort of design or ability to do an architectural feature that you've never thought of. It's that outside eye can sometimes be a changing point. So what are the advantages? I think realize we've been talking about advantages all this time a lot. So a lot of these things you see are kind of cyclical inside of this presentation. But one of the, you know, we've talked about the lightweight, the minimal use of materials, but the prefabrication, the fact that most of this work happens in the shops of the fabricators, in your shops, etc. This is an advantage compared to traditional building arts that send someone to the field who's really the craftsman. Of course, we have craftspeople and tradespeople on the field to actually install these, but the installations are very short time, and a lot of the really detailed work gets constructed off-site. So that is an advantage for sure, less installation time. There's a lot of other advantages here we can speak to. And we get into like the durability, the loads, you know, knowing that the right fabric structure can hold up to, you know, whatever weather conditions, or tensile structure will hold up to the weather conditions that it needs to hold up to. And it's just about designing to those conditions. Always like to include just shots of someone walking on a fabric structure, because often, you know, if not much exposure, the sense of a fabric structure is an awning or a light shade structure. And that's a big part of the industry, and we don't want to forget about it, and we want to promote it, but we also want to give this sense that there's kind of a big diversity in there. And then there's just the visual aspects of, you know, what's going on and how this might accent the whole architectural place. Fabric lights beautifully, and I don't care what it is, but it lights beautifully. I mean, I've seen beautifully illuminated just building awnings on structures that are more part of PAMAs than our work, but just the right lighting on that fabric really makes it come to life and really changes the whole architecture being present. Considerations in design, and speak to quick, our second course, this is the first course, and our second course is really gonna take what here is essentially a couple slides, and we're gonna expand that into a full course. And that course will present to you in this sort of format in the early part of next year, and we're aiming for a March release to let you start to give the course. As we've talked about, not all fabrics are the same. They don't have the same needs. It's what are you using them for? Symmetry, the economics of it, you know, whether you're building a frame, and this is where you might have expertise. You might even have an example of something that you can speak to. Again, there's a lot of material here, so we don't want to go off course too much, but paint yourself as the expert, because you have some experience that can add into this so it doesn't feel like a canned presentation. And then we can talk about timeframes a little bit. You can talk about timeframes in your shop. Now, we all know how COVID has disrupted timeframes for getting materials or building, things like that. But there's some typical ones. And, you know, even on larger structures, it says 2+ years, and I know very few larger structures that manage to get done in that time frame. That's still a pretty minimal time frame. And this is the last part of the course here, and I know we're running tight on time, and so we'll try to hurry through this. It's just, this is again, we're kind of circling back. The first we started with applications, so now we might say, well, where do we find those things applied? Instead of shade structures, we're thinking about parks. And we're thinking about, you know, residential applications, thinking about interior spaces. You know, you see a lot of different frameworks here, like some are framed, some are free tension structures. So we're seeing different applications fall into different usages. Awnings, covered entries, we're trying to give them imaginations, because this is leading into where do they have a project that might use a fabric structure, a fabric membrane structure. Hospitality industry is a big one. Covered tables, outdoor dining. I think the increase in covered outdoor dining since the pandemic has driven a lot of business into this industry, and I don't think that's going away. It's going to be an interest. People love being outside, no matter what. It's always a nicer environment. And there's a lot of studies on that. Protected public spaces, whether large scale or small scale, it's again giving that weather protection, whether rain or just shade. Pavilions and amphitheaters. Now we see some really large projects on grand civic scale, but also it can be done with a simple shade structure that has some music inside of it or something enjoyable. Event structures, there's not everything in fabrics lend themselves really well to events because, again, the sustainability, the minimal materials, the quick installation. So there's a large innovation field, which has been a lot of my background in membrane structures for events. Museums, museums want to stand out. They want to be artistic. They want to have design features that are rememberable. So as far as that goes, it's a great place to innovate with fabric structures, do really beautiful work. And then we go to some opposite sides, sports facilities. It's like we need the affordability here. So we need to be able to do large covered, large enclosed space. Again, the air supported come in, but not always. Sometimes they're frame supported, like in the upper right. Agriculture and industrial, there's a large use of fabric structures. Now, this is not really going to catch the eye of the architect so much, but you never know where there's some beautiful applications at airports where it's like they don't have the ability to do a custom architecture piece everywhere, so they use a little bit of sort of more industrial combined with some, nicer architecture or more finished, you could say, architectural approach. Stadiums, grandstands. This is a given that fabric is a choice because of span, cost, ability to build. Airports, bus, train stations. These are all very large scale, but there's a lot of fabric structures that are on a very small scale that are very effective in a local setting, local small regional setting. So, and we put this in here, because it's kind of, this is where your dialogue gets with the architects more question and answer. It's like, this is where, do they have something that this might fit into? And I find that pretty much every time I give this presentation, there's at least one project where they want to consider it and they want to talk about it afterwards, or they want to find the application. And like I've said before, this might not be an application for my company, but probably if it isn't, I know who, or can figure out very easily who in the industry is going to best serve their needs and still paint myself as the expert that way.
I almost think, Mar, we need to add a category for conservatories because because it is such a, something like the Eden project is obviously it's a very beautiful building, but in fact it was an extraordinarily pragmatic decision to use ETFE for the Eden project from a span and a light transmission point of view.
That's right. ETFE really gives that advantage. Plants love it because it doesn't filter out UV. We're still figuring out how this can be ended. There's a whole road, and Megan will talk about that a little bit, but where, they're getting credit, you're going to have to ask Jill and apply early when you kind of go and get these things booked. You need to let FSA-AIA know in advance so they can register the course with the AIA, and there's a whole process for getting the architect's credit. But this is what helps get you in their door. They need continuing education credit, and why not learn something? We're also making sure you have a place to end with your information up there. You're the important person who is giving this. It's to support you, but it's also to support the whole industry. So just want to, now's maybe a good time. We can jump into any questions. We are a few minutes over, but I think there's maybe a couple important questions. Dave, do you want to, or?
It's funny, I was answering them as I went, and I went back to review them in case we wanted discussion on it. And then I lost my question. Oh, here it is. So there were a few. The first one from some guy named Sebastian saying, "Isn't it a little early for a Christmas tree?" And I just have to say, no, it's not too early for a Christmas tree. There was a question when the full presentation and slides might be available. Someone might use it.
The whole presentation will be available at the very beginning of the year. We're still doing a lot of adaptation to this presentation. It was more about getting a format for the presentation, and now if you've watched this and you have thoughts or ideas for it, please feel free to send it through to the FSA or to myself if you have my information, and it will get incorporated into it before it's re-released. But we're gonna aim for sending it out right at the beginning of the year, so you could start to schedule now to actually give accredited courses. And we're going to be following up with also a very brief just what the overview of this course is and the learning objectives, because that's how you get it scheduled. You present that to the architects, you ask them if they want to schedule the credit time and the presentation and get it scheduled. So it will be available for you by the beginning of the year. And we will be doing another one of these presentations, more not so much teaching you all, but a direct one for architects in the beginning part of the year, which you're welcome to watch, to have one that's more just, oh, here it is, geared for the architects, trying to hit our time marks and not go over.
There were a number of questions, Mar, that relate specifically to an appetite for more detailed and technical information, specifically around interior projects. So more detail on fire, acoustics, some appetite for recyclability and impact on the indoor environment, particularly when we're talking about polymers and the potential for off-gassing. Do we think that might be covered in the second presentation, or?
Yeah, I do. I think the second presentation, just to give you all the kind of the main description of it, is to experience the art of designing fabric membrane structures. We're going to look at design and engineering, form finding, water flow, details, interior and exterior, fabrication detail and development, and give architects a basic of how to start to apply the principles of design to a project. We're not trying to teach them, we're trying to get them to understand the principles, because if they can understand some principles of design and know what details are important, they know how to integrate with you, the designer and the fabricator, for getting it done. So that's going to be the second course, and the idea is to get in with this overview course and then be able to give the second course.
It almost feels like there might need to be more than two, doesn't it? I think of the presentations I've given, and we could do a whole talk just on the form and structural implications. Would be very easy, and but sort of more detail around those other aspects is also so important.
Right. I think it is, and yeah, we know this can be endless, and there's a lot of background and effort, I could say, on FSA's part about how to expand resources that can be present, kind of presentations, informative, really get the information out there about what our industry does. That's really being looked at multiple levels, not just this one, but how do we get other information to architects, more monthly, and to developers, et cetera. This is being looked at a lot right now for the board. And, it's a volunteer board. I want to say, like, the new ones are up, but if you're considering trying to make a difference, please consider maybe, joining the board next year around convention time, because there's a lot of work to be done in promoting our industry and kind of getting it more known.
We had another question about whether the presentation is accredited yet.
It is accredited. It is accredited. Both are by the AIA, but it's more about the FSA's board final release. So that's a little reason we're doing this, is we wanted to see this feedback. We want to take this feedback The whole board's putting in feedback and mixture into this presentation that hasn't been completed yet. So we're this is an early presentation, and it's still in final development, although the the form of it, I think, is pretty well set. It's more like what's featured, what's talked about, what details are or are not there, how to succinct it, because no matter what we do, it's going to be hard to fit it in an hour. There's just too much, and you have to try to fit that zone.
I think I'm going to jump in here. I think that's all the time that we have today. So any other questions that people have, feel free to send them in. You can put them in your survey also, and we can get those answered. But thank you so much, Mar and Dave. Do you have any other comments to add before we wrap things up here?
I don't think so. I really appreciate those who came today to listen, and especially those giving feedback now or giving feedback later. It's very welcome. Again, this is trying to make something for you all to get in front of the architects. So,
Thank you so much. So I think Mar mentioned this, but as a member of IFAI's Fabric Structures Association, this course will be available for you to present to your local architectural firms. So if you're interested in this course, please reach out to Jill Newman, and that's jmnewman@ifai.com. And make sure you're paying attention to our webinar calendar. We're continuing to add more webinars, so check that out by visiting ifai.com/events. Otherwise, finally, there's going to be a really brief survey when you guys close out of the webinar. So we would really appreciate it if you would put your comments in there. Otherwise, thank you everyone so much for attending, and have a good rest of your day.
thank you all.
Thanks, Megan. Nice to see you, Mar. Thanks everyone for joining.